let's look at how to find a reference angle. Reference angles are for angles that are larger than 90 degrees or negative angles. For one of these angles larger than 90 degrees or negative, we want to use a positive acute reference angle, which is found by the terminal side in the x-axis. So let's look at some specific cases. For an angle in the second quadrant, like this one here, we would want the angle between this terminal side and the x-axis, so this angle here. We'll call this theta prime. This would be our reference angle. And we can see that these two angles together should add to be 180. So we can find the appropriate reference angle by doing 180 degrees minus theta, or pi minus theta if we're in the case of radians. For an angle in the third quadrant, once again, we want to make an angle with the terminal side in the x-axis. So that's this angle here. So we can see to actually find this angle, theta is bigger than 180 degrees, and we look at that change from 180. So this is actually theta minus 180 degrees, or theta minus pi in the case of radians. Finally, for an angle in the fourth quadrant, to look at the terminal side in the x-axis, we would need this angle here. We can see that this way we're looking at how much left we have to a full rotation. So this is 360 degrees minus theta, or 2 pi minus theta. Let's try to find the reference angle of 325 degrees. Well, if I think about what this looks like, 270 is the 3/4 way rotation, so 325 is going to be somewhere in the fourth quadrant. So that means this would be 360 degrees minus 325 degrees, which is 35 degrees. Next, let's look at the reference angle of negative 170 degrees. So if I draw my quick sketch, we're moving in the negative direction. If I do a straight angle, that would be 180, so negative 170 is a little less than that, about right here. But in order to do this properly, I need to first convert this to a coterminal angle by adding 360 degrees. That gives me that this is an angle of 190 degrees. So my reference angle for something in the third quadrant said that I should take that angle and subtract 180 degrees. So my reference angle here is 10 degrees. Next, let's look at 490 degrees. 490 degrees is bigger than 360. So let's first start by finding a coterminal angle that's between 0 and 360. So 490 minus 360 is 130. So if I want to quickly sketch that, 130 is going to be between 90 and 180. It's going to be somewhere in the second quadrant. So those reference angles are found by doing 180 degrees minus the initial angle. So the reference angle here would be 50 degrees. Let's look at the reference angle of 3 pi over 4. So pi over 4 is 1/8 of the way around. So if I draw this, this would be 1 pi over 4, 2 pi over 4, 3 pi over 4. So this is in the second quadrant. In that case, in terms of radians, we would do pi minus the initial angle, which is pi over 4. Next, we have the reference angle of 10 pi over 3. This is bigger than 2 pi, so I'm going to remove a 2 pi, which I'm going to write as 6 pi over 3 to get a coterminal angle of 4 pi over 3. So when I sketch this, 3 pi over 3 would be equal to pi. That would be half a rotation, and I have about 1/3 more. So about right here. That's in the third quadrant. For the third quadrant, in terms of radians, we do the original angle, which is 4 pi over 3, minus pi. So theta prime is equal to pi over 3.